Today we're going to be talking about differentiation formulas. Question. I do somewhere. I don't know where it is. Let me look as soon as we get through the lesson. You follow along with that dude right there. Okay, so f of x is equal to a constant. If I say have y is equal to 4, what kind of shape does that make? What's the slope of that line? So what's the derivative? Yeah, so if f of x is equal to a constant, then f prime of x is equal to 0. Suppose f of x is equal to x. What's the slope of x? 1. So therefore, f prime of x is equal to 1. Suppose you have a constant times x. What's the derivative of a constant times x? The constant. So you have 2x, and the slope is 2, right? So f prime of x is going to be equal to c. So the question is, suppose we have f of x equals x to the nth. What do we take? How do we take the derivative in that situation? I'm going to back up to a problem that you guys had, which was f of x is equal to x to the 5th. Anybody had that on their worksheet? You figured it out? So let's just review how we set that up. We said f prime of x is equal to the limit as h goes to 0 of x plus h to the 5th power minus x to the 5th, all divided by h, correct? And that brought back to Pascal's triangle. This is all super important for you to be able to follow exactly what's going to happen with the shortcut rule. Pascal's triangle, 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, what? 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. And that's the 0 power, 1st power, 2nd power, 3rd power, 4th power, 5th power. So what's very interesting about Pascal's triangle, you guys were able to add the previous 2 entries in order to get the one below it, correct? But please note this. Please note that it always starts out with 1, correct? And then the second one is the power. Agreed? So if we expand this, you said you have the limit as h goes to 0 of, we know we have x to the 5th, x to the 4th, x to the 3rd, x squared, x, and then you got h to the 5th, get an h, h to the 4th, h to the 3rd, h squared, h, right? And then you got this minus x to the 5th. Like we get that whole beast, and then the coefficients, again, there's a 1 here, and then the second one is the degree, right? And then 10, 10, 5, and whoop, and 1 h to the 5th. What happened when you did this? What happened? X to the 5th and negative x to the 5th went away. Everything else has, so you have the limit as h goes to 0 of 5x to the 4th plus 10x to the 3rd h plus 10x squared h squared plus 5x h to the 3rd plus h to the 4th. Can we now allow h to go to 0? And when we do, what happens? All that garbage goes away, right? That's what we're going to see right here. If we have the limit as h goes to 0 of, we're going to set f of x equal to x to the nth, and we're going to find f prime of x. So that means we need to take x plus h raised to the nth power minus what? X to the nth all over h. I'm going to expand this. the limit as h goes to 0 of, let's be careful, what are we going to start out with? X to the n. Everybody good there? What are we going to end with? Okay, so I hear a couple things that are correct. We're going to have an h to the nth and a minus x to the nth. Well, we all okay with that? So my next term, do you know what the coefficient will be of the next term? N, it's always the degree. The second coefficient is always the degree. What then happens to the degree of x? And what am I going to pick up? An h. The next one, I'll have some other constant, which I don't really know. What's going to happen to the degree of x? And I'll pick up and then I'll get another constant times x to the n minus 3 times h to the and that pattern will just continue to go on and on and on and on, correct? Until we finally get to h to the n. Question. Eventually, it will be h to the nth. But we start by picking up 1, h, and then 2, and then 3. Notice this, Logan. The degree is n. And if you take the degree of the x's and the n's, they will add to n. So n minus 1 and 1 makes n. N minus 2 and 2 makes n. The degrees will always add up to that original. You guys are doing excellent. All divided by h. It looks horrible. It's going to get really, really, really good. What happens? The x to the n's cancel, right? I'm going to drop those off. And then everything else has an h. Can I divide an h off of everything? And if I divide an h off of everything, what's left there? Nx to the n minus 1. What's left here? Cx to the n minus 2 times h to the 1. Because we divided off an h, right? Then c sub 2 times x to the n minus 3 times h to the second. All the way until we get an h to the n minus 1. Let's plug in 0 for h. What happens if we plug in 0 for h? Everything except for the first term disappears. So what that means is if f of x is equal to x to the n, then that means that f prime of x, the derivative, is simply this. You take the power and move it in front, x, and then you reduce the power by 1. So if f of x was equal to x to the 5th, then f prime of x, what do we do with the 5? Put it in front. What do we do to the 5? Minus 1. Go ahead. No. No. Watch. What, trust me, you're going to get it. So suppose we got, so what's the derivative? Yeah. Just for that assignment, as you move forward, you don't. Yeah. So 4x to the third. If we've got a constant in front, we just drop that in front, we get 12x squared. Yeah. Look at that. Cole and Braden, I'm done with you guys now. But Cole and Braden, I just wanted you guys to see this piece again, that you would understand why we come up with that. That is through the binomial expansion that we get to that part. I know you know what a derivative is and how to find it, but I don't think you actually remember why we get from here to here. And now you got a better chance of seeing as we move forward. Question. And that's exactly what we'll do. So it's trust me guys, it's great. This is a beautiful day in calculus. The derivative is n times x to the n minus 1. That's the rule. Suppose you have multiple functions that you're adding and subtracting. Well, so then you just take f prime plus g prime. You just take the derivative of each one and add them together. And if you're subtracting, you just do f prime minus g prime. You just subtract the derivatives. We cannot do f times and f divided by yet. We're going to have to reserve that for a different moment. So flip it over, and you're going to get a chance to try these derivatives. Couple ways to look at it. The first function, it's a constant. What's the derivative of a constant? 0. So you know that. I want to show you how the power rule, as we call it, the power rule works here. This is 5 times x to the 0, because x to the 0 is 1. Everybody see this is 5x to the 0? So if we use the power rule, the 0 drops in front, and we get f prime of x is 0 times 5 times x to the negative 1. Well, 0 times anything is 0. So you don't have to do that every time. If you see a constant, I expect that you're going to be able to say the derivative of a constant is 0. Watch what happens here. This is 4x to the first power. So f prime of x, we drop the 1 in front, and we get 1 times 4x to the 0. What is 1 times 4x to the 0? 4. So therefore, as you can see, the derivative of 4x is just 4. If you have multiple pieces being added together, as Riker said, you just take the derivative of each part. What is the derivative of negative 3x? Negative 3. What's the derivative of 5? 0. And you should be able to look at that and think, oh yeah, that's a line with a slope of negative 3. The derivative will be negative 3. So now, remember you had to plug the x plus h into here before? And you're like, shoot, that took a lot of work. Watch this. What's the derivative of 5x squared? 10x. What's the derivative of 10x? 10. What's the derivative of negative 3? You're done. That is pretty cool, isn't it? We're going to do f in a second, but first we're going to glance at k. It's totally optional, okay? f of x, look at that ridiculous thing. Can you imagine plugging in x plus h into that type of a function? Wouldn't that be just really, really torture? Watch how quickly we're going to make just that look simple. Derivative of 2x to the 7th minus plus minus plus plus minus. Does it matter that you got 1,943,789,432 on the end? No, that's just simply where it's located. That doesn't change the rate at all. That's the derivative. We did it that quickly. So I know that you guys can handle those types of problems. What if we get examples like this? Your tendency is to lose connection with your notation. And I don't like to be all snotty about the notation, but it does matter. And so I am simply going to write f of x because I'm going to rewrite the function. I'm not taking a derivative yet. I'm writing as 8x to the 5th minus 3x cubed plus, does anybody know how I would rewrite 1 over x squared so that it's written as x to a power? X to the negative 2. In order to make the power rule work, you have to have x to a power minus x to the 1/2. Now I'm going to take the derivative. F prime of x is equal to, what's the derivative of 8x to the 5th? 40x to the 4th minus 9x squared subtract 1, negative 3, minus 1/2 x to the negative 1/2. You can't leave your answer with negative exponents. So therefore, we rewrite f prime of x as 40x to the 4th minus 9x squared minus 2 over x cubed minus 1 over 2 roots of x. I want to rewrite letter G so it has a power. How would I rewrite it so it has a power? Negative 3x to what power? 5/3? Negative 5/3. So I have negative 5/3 times negative 3 times x to the, if I subtract 1 from negative 5/3, what do we get? Negative 8/3. What's negative 5/3 times negative 3? Positive 5. So I get 5x to the negative 8/3, or 5 over x to the 8/3. Trying 3 more, then you can start your worksheet on this. You try h on your own. Go. Oh, sorry. Negative 12 over 35 x to the 1/7. 7th root of x is fine. No, I would say that if you leave, though, your answer is cubed root or square root of x cubed, technically that's not simplified. You would need to write it as x roots of x to be simplified as a square root, right? So, or you could write this as x to the 3 halves. You would say, well, we'll just leave it as a fractional exponent. So if it's a square root, often I'll write square root or cube root, but if it's anything that's greater than 1, I usually write it just as a rational exponent. Okay, what's different about letter I? Thank you, Lexi. I made sure we had letter I in there for you today. Yeah, so I want to be clear, folks. This is the big mistake that people make. They take the -2 and they dump it in front right away. You can't do that. You can't do that because here you have an entire function being taken to a power. You must write it as a constant times x to a certain power. That's how it has to be written. And right now, this is a constant times x all to a certain power. That does not work. So we first must reconcile this whole parentheses deal that's going on. So I'm just going to rewrite f of x. I have not taken a derivative. If on your work, on your test, you start writing f prime at this point, I'm assuming you're telling me that you're taking a derivative. And then I get confused. So it's important that you just rewrite f of x is equal to. All right, so now I know that you're rewriting it. I can follow your work. So how am I going to do that? How do you want to rewrite that? Where do I even start? Okay. How about I use up the negative? Can I do that? Negative. What happens if I use a negative exponent there? The 1/3 becomes 3, and the x becomes -1, right? So I have 3 over x. Isn't 1/3 x the same as x over 3? Isn't 1/3 x the same as x over 3? So if you want to use up the negative, just flip it. Question. Yes, that's fine, and that's where I'm going here, okay? So then I'm going to continue to rewrite this as negative 3x to the -1 squared. Because I want to make sure I have x to a power. And now I'm going to rewrite it as 3 squared is 9, so I have a -9 x to the -2. So a lot of people ask, they say, well, Mr. Gens, am I done? Have you taken a derivative yet? You've only rewritten it. So now I write f prime. I'm going to take the derivative, which is 18x to the -3, or 18 over x cubed. That's the derivative. Last example. I'm going to rewrite it. F of x is, how do I rewrite the square root of 5x? The square root of 5 is the coefficient. Then it's x to the 1/2. You see that? You want to raise a coefficient times x to a power minus the square root of 3. Isn't the square root of 3 just a constant? What's the derivative of a constant? 0. But people on the test all the time, they'll write this as 3 to the 1/2. They'll dump the 1/2 in front, 3 to the -1/2. They'll say, okay, the derivative is 1 over, let's see, 2, 3, the -1/2. I need an x in there somewhere. Yeah. Well, that's just complete voodoo right there. Okay? You've got the square root of 3. The square root of 3 is simply a constant, and the derivative of a constant is 0. So we know that that's just going to go away, plus x to the 1/2. All right, I'm ready to take the derivative. What do I do? Put the 1/2 in front. So I'd have the square root of 5 over 2 times x to the -1/2. What's the derivative of the square root of 3? 0 plus 1/2 x to the negative 1/2. So it looks like I get f prime of x is equal to root of 5 over 2 roots of x plus 1 over 2 roots of x. Hey, what do you know? They have common denominators. How about the root of 5 plus 1 over 2 roots of x? The power rule is an awesome thing. It's going to make our ability to do calculus quicker, more efficient, better. You're going to use it every day for the remainder of the year. And you will never, again, have to do f of x plus h minus f of x all over h, except when you're asked to do that for one last time on your next test. That's it. You can let it go. That's it.